this recurrence relation by z to the power r, so that the first terms becomes the genetic functions gz, and gradually we will solve accordingly. Uh, we multiply, this is your genetic function, so first term is ar, so multiply this by z to the power r, and then take the summations. Okay, so when you are taking the summations, so what are the steps? This is the steps. Okay, first step is multiplication by z to the power r, we will get this one. Now you see here, the suffix is r, and the exponent, that means the power of z is also r, so it's okay. Okay, but here we have a r minus 1 and here we have a r, so make it r minus 1. Here it is r minus 2 and here r, so make it r minus 2. Okay, so what you do here, if you want to make it r minus 2, that means we have to include subtract to move z. So to compensate this, we multiply this by z square. Okay, so that this becomes z minus 2. Okay, and this is as usual, no problem. Now you see, again we have to, because you see this is the form of the uh, generating function, so we should have here some p or m, whatever may be here also. So what you do, take r minus 1, instead of r minus 1 we are writing here p. You see here, we are writing here p, and what is the p? P is equal to r minus 1. Okay, so that now it is in the form of genetic function, but still we have a problem, that is this p should be start from 0, but here p starts from 1. Okay, and similarly for this two also, here you take p is equal to r minus 2. So basically what is the step? Our aim is to ultimately uh, in these forms a r z to the power r, this. Okay, and this r should be greater than equal to 0. We have to put in this form, we have to put it into these forms. So what you do, once you convert this to apz to the power p, or here apz to the power this, but still p is start from 1, so subtract the unit first terms from here to get it. Now this becomes the genetic functions, this also becomes the genetic functions, and it is in the genetic function, and we have to solve this one. So these are the basic 3 steps we have to follow in each and every problem. Okay, now once you get the zz in terms of the z, now our aim is to explode this one. Okay, first you find the zz. Okay. Now what you do from this, uh, now we just proceed this one, p plus zz, or leave it. So first you take let give some equation. Suppose it is equation number whatever the given 3 or 4. So let 10 using the method of partial fraction, minus 7z plus 2 upon 1 minus twice z into 1 minus z whole square, and it is equal to a 1 minus z plus b1 minus z whole square. We have a z square over here, and plus one more c 1 minus twice z, multiplying both sides by the denominator, so that what we will get, this side if you multiply by denominator, so we have with only numerator, that is 10z square minus 7z plus 2. Okay, and this side you will get z square, so we have a 1 minus z over here and 1 minus twice z, plus b we have a 1 minus twice z, and plus c we have 1 minus z square. So multiplying both sides by the denominator, we will get this one. Now this expression can be expressed in this form. And we know the genetic, these are constant, A, B, C are the constants, and we know the terms of the sequence whose genetic function is 1 by 1 minus z, or 1 by 1 minus z whole square, or 1 minus 2z. We know these things. So we go for this. We have to find now there are two ways to find. Suppose we multiply each and every term and then collect the coefficients of z, z square, and the constant term, and then equate the coefficients on both sides. Suppose this side you are getting the z square, you see, z square, here we have a plus twice z square, so what will get? Twice a plus c is equal to 10. This is one equation. Similarly, we have the coefficients of z also from this side. Equate this, and similarly you will get three equations in three variables. Variables are a, b, c. That means we have to solve the system of linear equations. Okay. Now, suppose this is 5. We are not going to solve using that method. What you do here? This is the another way. Suppose if you put z is equal to 1, then what happens? This becomes 1 and this becomes 1. Then what happens? This is 0, this is 0. So A and C will absent here, this will absent, this will absent, because this is 0, this becomes 0. Remaining is this. So what you do, put z is equal to 1 in 5. So what you will get? Z is equal to 1, that means this side you are getting 10 minus 7 plus 2, and this side, this becomes 0, this becomes 0, you will get 1. So you will get b into minus 1. So this
b
equal
to 5.
b is equal to 12 minus 5 minus 5. It is
Minus.
Z square minus 5. How much it is? 12 minus, it is minus 5 it will be.
Yes.
Okay. B is minus 5. Now, how to get the C? How to get the C? See, if you are putting Z is equal to half over here, so this term becomes 0 and this term also becomes 0. Okay. So only this will non-zero. So next you put Z is equal to half in 5. So this is the way to solve the fractions. So what you will get? 5. That means it is 0.5, 0.25. It is. That means you will get 2.5 this. So how much you are getting? 10 by 4. 10 by 4 minus 7 by 2 and plus 2, and this side you will get b, this becomes 0, this becomes 0, you will get c into 1 minus 1 by 4. So what is the value of c? It is 4. That means 14, 14, 2, 2, that means 4, 7, 14 into minus 2, a half, it is 1 by 4. How much? C equal to how much?
So it is kind of minus 2 by 3.
No, overall C is equal to how much?
Minus 2 by 3.
Minus 2 by 3. Is 10 minus 14 plus 4. 10 minus 4 by 4, and this is C into 3 by 4. This is So C is equal to this side you will get 10 and
Minus 2 by 3, sir.
no, minus 2 by 3 I will get it. So it is 4 okay, so 10 minus it is 14 plus 8. So it is 4 by 4 and
Minus 4 by
minus
3.
is equal to C into 3 by
Yes.
4. So C will come how much? 4 by
Minus
3.
4 by, yes.
Minus or plus?
Minus,
Plus
sir.
plus
Plus.
4 by 3.
Yes,
Plus
sir. Plus 4 by 3.
Yes, sir. Plus 4 by 3.
plus 4 by 3 will come, okay. And now just put the values of this over here. So now if you put z equal to half or z is equal to 1, so you will not get a. So what you do here, take the constant term, any one of them, you take it. So what you will get? If you put these values, so take the constant term. Constant term will be how much? This side is a, okay. Also a, and here we have a plus b, and this is a, this is plus b, and this is c plus c. This equal to this side. What is the constant term? This is 2, okay. And a equals to how much? 2 minus b. Minus b equal to how much? Plus 5, and minus c, it is 4 by 3. So whatever may be the value, it is 6. It is 6 plus 15 minus 4 by 3. So how much it is? 2, 17 by 3. So 17 by 3. Okay.
Sir, please explain a plus b plus c equals to 2, that part.
So you see here, if you are taking this constant term, here we have a coefficient of z square in this equation, okay. We have a coefficient of z square, coefficient of z, as well as the constant term also. So this side also we have a coefficient of z square, coefficient of z minus 7, and the constant term. So what would be the constant term? You see, if you are multiplying this and this, you are getting 1 minus 3z plus 2z square. So constant term is a. So this side you are getting a from this term. Here we have a b minus twice bz, so constant term. Twice b is the coefficient of z, and b is the constant, plus b, they have written here. And this is c minus cz square. So for this, c is the coefficient of z square, as well as c is the constant term also. So from here we have a c. And this side the constant term is 2. You are getting this. Similarly, you can get
Sir,
two more. You are getting two more equations also. You can put. Suppose if you want to take the coefficients of z square. So what you will get? This side coefficient of z square is 10. Okay, and this side how much you will getting? It is plus twice. So twice az square, and plus c. Okay, sorry, minus c. Minus c. So this is 10. Now put it here. C is equal to whatever 4 by 3 you will get. You can get the values of a. Okay. Here you have to put the value of both b and c. So you will get the same value. Okay. So check this one, whatever may be.
yes, sir.
Okay. Now once you get the value of this, put it here. Suppose a, b, c you are getting. Okay. A, B, C you are getting. So I am not going to put it here. So GZ is equal to how much? ZZ is equal to, now come to 4, equation number 4 and equation number 5. I am not going to put the values of A, B, C. I would only like to show you how to find the values or how to use the partial fractions. But now when we are finding the solutions, we are considering only these terms and these terms. Okay. So ultimately, what can you write? Suppose ZZ, whatever may be the value, we have a ZZ, this is equal to A by 1 minus Z plus B by 1 minus Z, whole square, and third one is C by 1 minus twice Z, whatever may be the value of Z, A, B, C. No, don't bother about it. Now, Gz can be written as what? Gz can be written as this Arz to the power r, okay, and is equal to a, whatever may the value. Here a will come 17 by 3, whatever may be. And what is the uh, generating functions? You see the list. You see the list. Previous class we have written a list. You see the list. What is the coefficient of, what are the member of the sequence whose generating function is 1 by z?
So 1 comma 1 comma 1.
1, 1. That means exactly 1. So it is how much? It is simply a 1. So z to the power r here. R greater than equal to 0. Okay. And
Yes,
plus you simply put the value of ABC. This side is B. This is the generating function of 1 minus z
N
whole square.
plus.
It is n plus 1. So we have a r plus 1, z to the power r, and plus c, and this is the generating function of, it is 2 over alpha to the power r. So
Minus
2 to, no, 2 to the power r. You just check it. If we have a to the power n, then it is
so 2
1 minus
2 to
1
the
minus az, like this. Okay. So we are getting this one. Now equating the coefficient of z to the power r, you will get, equating the, you will get this side you will get ar, and this is equal to, suppose, a plus b into r plus 1, and plus c into 2 to the power r. So this is, now put the value of abc. Okay, I am not going to write this one. So this is your solution. Is it clear?
Yes, sir.
Yes.
Okay.
So
Now go to the next.
should we have to put the values of A and B?
I just simply put 7. Actually, you have to put it here. In fact, 7. It is 17 by 3. B comes how much? Minus 5. And C comes how much? Minus 4 by 3. Like this. Okay?
Yes,
Is
sir.
it? Now put it the value. Now come to the next question. Okay. And one more thing. Uh, Using the generating functions, we can solve only linear equations. Okay, and here we are solving the problems linear recurrence relations, linear reconciliation with constant coefficients. If it is not constant, then today I will solve one problem where the coefficient is not constant. Okay, but before that you solve one more problem and do yourself. Question is solve using recurrence relation. Solve using generating function. Okay. Generating function. Problem is sometimes it is given in terms of an also. So instead of just practice it, I am writing, instead of r I am writing an. Okay, an minus 8, an minus 1, this is equal to 10 n minus 1. Okay, if you want, then you can write the r also, no problem. But questions in questions, both r and n comes this one, and we have some conditions also. A naught is equal to 1, suppose. Okay, A naught is equal to 1, a simple problem, solve it. So how to write the solution? Simply write the questions. Given an minus 8 an minus 1, that's equals to 10 to the power n minus 1, and a naught is 1. Suppose it is 1. Okay. Now, what should be the next step? Consider the generating function. Let the required, okay, required generating function is Gz. And that's equal to how much? An z to the power n. That's equal to this. Now, what should be the next step? This side you are getting generating function is defined as an into z to the power n. Here we have an. So what you do, multiply both sides by z to the
Z
power.
to the power n.
Okay. So do yourself. Okay. Everybody try to solve it. Everybody try to solve. I will also solve this one, but don't see this one. Do yourself. Sum of from, we have a naught, that means we have to include from a naught is given, so we have to sum of from 1. Okay. N 1. Okay. And to infinity, no need to write that one. So what will get? A n z to the power n. Okay. And minus it is 8 a n minus 1 this one, okay, into z to the power n. And this side okay. Now solve it. Minus n. Is this step clear? Is this step? Here it is start from n is equal to 1. I am including one more term, so we subtract the first term here. Now
Yes, sir.
Yeah, this becomes the genetic function. Okay. Minus. Next step is to, here we have to match this one, n minus 1, n minus 1. So what you do, 8 and here put p equal to n minus 1, so that p goes to 0, and this becomes how much? Or multiply one more steps, leave it, leave this one. So what we will do, it is n, so you are writing a n minus 1. Directly you can write it z n minus 1, so we divide this by z, so multiply this by 8z also. Okay, and this side is again n minus 1, so we need to make it n minus 1, so what we will do, and here n will come, and here n will be equal to 1, n to the power n minus 1, z to the power n minus 1. So again we multiply this side by z. Okay. System stepwise we proceed this one. So this is nothing but gz minus a naught. Value of a naught is given, it is 1. Okay. So here you can write the 1 also, minus 8z, and you may write it. Now you write n minus 1 is p, and then p, n minus 1 is p, then p greater than equal to 0. So we have the apz to the power p, and this equals z, and here also we have same thing, n minus 1 and p 0 n to the power p z to the power p. Okay. So now put the values of a naught. Value of a naught is given, so we have a gz minus 1. You see, in the problem it is given a naught is equal to 1. It is given.
1.
Okay, so I am writing here 1, and then minus this becomes z. Okay, and this is the, what is the value of this? Z into alpha to the power n. You see the list, alpha to the power n. This is the
So 1 by 1 minus alpha z.
alpha z. So we have alpha equals to 10. So alpha z. Is it clear?
Yes, sir.
Okay. Now it is easy. Now you find the values of gz. Find the value of gz. So how much you will get? 1 minus, you will get 1 minus 8z. z. Okay. 1 minus 8z, and put it this side. So what will get? Z by 1 minus 10z, and it will be plus 1. Okay. So that zz will be how much? You will get 1 minus 10z. So 1 minus 9z, 1 minus 9z divided by 1 minus this is 8z into 1 minus 10z. So this is your zz. Okay, but this is your genetic function. This is your genetic functions. But we need to find the solution of the recurrences. That means we have to find the an. So here we are finding the genetic functions, but not the value of an. How you find it? Again, suppose it is 3. So let same procedure using the method of partial fractions, we will solve it. 1 minus 9z, 1 minus 8z into 1 minus 10z. So it is a linear and it is a quadratic, so it is a proper fraction. So we may write it like a upon 1z and plus b upon minus 10z. Okay, and again multiplying both sides by the denominator, this side you will get 1 minus 9z, and this side a times 1 minus
1
10.
minus 10z plus b into 1 minus 8z.
Now put the values. Find the values of a and b. Now we are not going to find the value of. How you get the value of a? How you get the value of a?
By putting z equal to 1 by 8.
Yes, and to find the value of b, we put z is equal to
1
1
by
by.
10.
So find the value of a and b. Put z is equal to 1 by 8. We get how much? 1 by 8. This becomes 0. You will get a equal to how much? 1 by
1 by
8
2.
minus 2 by 2.
So 1 by 2.
Minus 1 by 8 half. It will come half. 1 by 2. Good. And put z is equal to 1 by 10. So it is 8 by 10. So 2 by 10, and here you will get 1 by 10. This also comes half or half. How much b? I am getting half here. You see here it is at 2 by 10, and this side you are
Yes,
getting
sir.
1 by 10. So it is half again. B is half.
Yes.
Okay. So Okay. So now put the values. Therefore, 3 implies Gz is equal to how much? It is half, and this quantity, this so we have uh, 1 minus 8z and plus 1 by 1 minus 10z. Okay, this. Now this is equal to how much? Now Gz is equal to how much? A n z to the power n, and this side you are getting the half. What is the value of this? It is minus, it is 8, 1 minus alpha z. So it is 8 to the power n z to the power n, and similarly this will be half, this half, and this is 10 to the power n z to the power n. Is it clear? Is this step clear?
Sir. Yes, sir.
So
Yes,
now
sir.
equating the coefficients of z to the power n on both sides. So what will get? This side is an, and this is half to both, and we have a 8 to the power n plus 10 to the power n. So this is your required solution. Is it? Is it clear?
Yes, sir.
Now we are going to solve the another problem. First try this one. Question is solve using generating function. Using generating function. What is the generating function? Recurrence relation is an is equal n minus 1 into an minus 1 plus n minus 2. Okay, solve it. How to solve this one?
So first we will simplify.
We have n minus an minus 1, an minus 2. Okay, so what you see here, n minus 1 multiplied by an minus 1, it is not the constant coefficient. It is not a constant coefficient. Suppose if you are taking n is equal to 7, so this becomes 6a6 plus 6a5 like this. So if you change the n, the coefficient will also change. That means it is not the coefficient. So how we tackle this problem? You see, we can solve it. These are the special type of problems. How to solve it? Suppose I am writing the solution. Solution. Simply write the question. Any initial conditions are also not given here. Sorry, it is 1. Okay. Now, so there are no hard and fast rule to solve such type of problem. So here we are using the exponential generating function. Okay. So consider the exponential function. So what is the exponential generating functions? Can anyone tell me? Exponential generating function an into z to the power n by n factorial. Okay, and here n. It is also a power series, but instead of only an, we have an by n factorial also. So suppose it is okay. So now what you do, we have n minus 1 over here, n minus 1 over here, this n minus 1. So how to compensate this n minus 1? What we do, we differentiate this. If you differentiate this, so how much you will get? How much you will get?
Sir,
See the
an
yes. An
n minus 1
z to the power, z to the power.
to the power n minus 1.
See the property of derivative. See the property of derivative. Property of derivative. See this one. Simply, you see here, I am not writing. You see, if it is the function, then what will do? Term by term derivative, because it is the analytic functions. Geometric function is the analytic, and that's why term by terms derivative are admissible over here. So differentiate we will get, simply you see here, we get n z to the power n minus 1 divided by n factorial. So this can be written as n minus 1. So n cancel out, what you will get? The n minus 1 upon n minus 1 factorial. But instead of n starting from 0, we have to take n starting from 1 over here. Is it clear? It is
Yes,
simple
sir.
derivative. Okay. So question is why I am taking the derivatives. You see here we have a n minus 1, and here we have a n minus 1 factorial. This can be written as n minus 1 into n minus 2 factorial. Okay, so n minus 1, n minus 1 will be cancelled out. And is it clear why I am considering this exponential term as well as why I am taking differentiation of this? By the way, next, once you this, now put the value of, it is 3 an, so implies g dash z is equals to how much? an is equal to n minus 1 an minus 1 plus an minus 4, this into this. Okay, leave it. Now you see this will be cancelled out. Okay, and you see here n minus 1 factorial can be written as n minus 1 into, you see here, this can be written as n minus 1 into n minus 2. Okay, so this n minus 1 and this n minus 1 will be cancelled out, and you will get a n minus 1 plus a n minus 2 into z to the power n, and this side you are getting n minus 2. Okay, but you see exponential, in the exponential geometric function, if we have a z to the power n, then we must have n factorial. So here we have a n minus 2 factorial. So here the power of j should be n minus 2. Is it clear? But here we have a n minus 1. That means we are introducing, yes.
Sir, z to the power n minus 1 was there.
Now n minus 1 it is here when we have a n minus 1 factorial over here. Okay, you see, we have to express gz in these terms. So if it is n over here, then here we have a n factorial. Here we have a n minus 1, power of z is n minus 1, so we have a n minus 1 here. But once you cancel out this n minus 1 and this n minus 1, so we have n minus 2 factorial in the denominator. So we have to make the power of z as n minus 2. How can you make it? We have a n minus 1 over here. So if you multiply this by z, then this becomes n minus 2. Now it is in exponential form. You see here? Is it clear or not?
Yes, sir.
Okay. But in this case, we have to consider n from 2 because we have a factorial. Negative is not admissible. So we have to take n minus 2. Now, just separate this one. What you will get? Z. So it is exactly the exponential form. It is exactly the exponential form. So now, so all are equal to gz. That means the first derivative. Now this equals z. I am writing p equal to n minus 2. Okay, so that sorry, p n minus 1 I am taking. Okay, p n minus 1 and p greater than equal to 1. So we have AP and z to the power p upon p factorial. Okay, sorry, p minus 1 factorial. P minus 1 factorial, and this is also p minus 1. Okay, and this becomes how much? Z, and it is n greater, so you may write one time p n minus 2, then p greater than equal to 0. It is AP z to the power p upon p factorial. Okay, now tell me, what is this? These terms.
So gz.
Just a minute. Just a minute. So see, gz. Gz, you see here, n greater than 0, an z to the power n by n factorial. And z dash, you see here, n start from 1, it is an, it is z n minus 1, and it is n minus 1. So you see here, you are getting the same thing over here. So this can be written as z into g dash z, and this is z into gz. Is it clear? So we have gz dash, this equals, okay, up to this, is it clear to everybody? Yes or no?
Yes, sir.
Any queries? I am asking to everybody. Any queries?
No, sir.
Okay. Now you see here. So gz is equal to how much? G dash z is equal to sorry, gz into I'm writing into 1 minus z is equal to z gz. Okay, and now we have to find the gz. How can you find it? All are the function of z. Now you use the calculus to solve it. Okay, we have to find. How can you find it? Any idea? Any idea how to find the gz?
Sir, we have done something x dash by x, integration of x dash by x.
Integration of
X dash by x.
yes. Okay. Let us try by that one. So integration by both sides. Integration both sides. Or sorry, integrate both sides. Okay. So what will get? Log zz. You are getting this side because if you are integrating f dash x by fx dx integration, so it is how much? Log fx mod value, of course. So you are getting this one, and this is integration of z by 1 minus z. Okay, is it? Now we have to solve it. So it is quite simple. It is equal to integration of 1 minus z plus 1, and we have a minus 1 over here with negative sign, and this is minus 1 minus z, it is dz, and it is minus integration of z dz. So how much you will get? It is minus z, and this side is log of minus z, so plus 1 is minus log of z. So suppose z is positive, otherwise we have to put the mod value over here. So now transpose this one. Actually we have zz equals to this.
Excuse me, sir.
Yes.
Why you have taken minus common there? Minus is there in the second step.
You see here, this is plus 1, this is minus 1, cancelled out, and this minus and this minus combined to
Okay.
give the plus. So it is the plus. So we have z into zz. This is equal to e to the power minus z, removing the z. So therefore zz is equal to how much? This is plus z. Sorry, log of this is 1 minus z. 1 minus z. So it is 1 minus z. Okay, 1 minus z. So it is e to the power minus z by 1 minus z. So this is a generative function. Okay. Now from here you have to find the solutions. So how can you find it? Now everybody try this one, how to find the solution. Once you are finding zz is equal to this. So how can you find this an? Actually, once you find these zz generating functions, from here we can find it, because e to the power z can be expressed in terms of the generating function minus z.
So we will put gz equal to the exponential generating.
By the way, after this, at least you find it, because after this it will take time to solve, because we have to express this e to the power minus z by 1 minus z in terms of again and we do not have any list of this e to the power minus z by 1 minus z. So but everybody worked out in this. Okay, we have the list of 1 by 1 minus z or 1 minus alpha z like this, but we haven't this e to the power minus z by 1 minus z. So everybody try to solve this one. Okay, everybody try to solve this one. So definitely you will get some member of the sequence. So it is your homework. Okay, homework is find an by exploring e to the power minus z by 1 minus z in terms of the sequence. So everybody try this one. So next class again we will try to solve some problems, okay, from this as well as from the characteristics equations. Okay, so everybody solve these problems. These are very easy and interesting also. And what is the next? Okay, in the first module. So in next class we will solve more problems related to this genetic function as well as the method of the characteristics roots. And then in the coming week we will start the module 3, or we have to take the test also. So what is the remaining portion of the module 1? Predicate and quantifier. No, mathematical induction, method of proof we have completed. Is it completed, method of proof?
Yes, sir.
Okay, but
Yes,
mathematical
sir.
mathematical induction,
Yes, sir.
Yes, sir.
mathematical induction, is it completed?
Yes, sir.
No.
Yes, sir.
Confirm.
We have solved the problem, sir.
Using mathematical induction.
Yes,
Okay,
sir.
no problem. Then the remaining part is the predicate and the quantifier and well ordering principle. Recursive definitions we have already studied over here in the module 2. So module 2, this is the last topic of the module 2. And in module 3 we have a sets, operational sets, computer representation of sets, relations, properties, classification of the relations, closure, matrix representation of the relations. So this is the, so everybody know these things, the set operations or the how to represent the set or the computer representation of the set. And this is new, matrix representation of the relations. I think everybody are familiar with the relation.
Yes, sir.
Okay. So do you know the diagram? Yes or no, sir?
No, sir.
No. Matrix representation of relations?
No, sir.
Okay. So we will discuss those topics which are unknown to you. This set operations or sets, operation on the sets. These are should not be the topic of this third semester. But we will start from the everybody at least priorly read this set, operation of sets, relations. Little bit we will discuss these relations also. Okay, and then how to represent set in computer or matrix diagram. And again topic is the function and their representations, classification of functions, Warsaw's algorithm. Probably you know the Warsaw's algorithm.
No, sir.
So data structure is there.
Yes, sir.
Data
We
structure
just started
is in,
stack in data structure, sir.
no, it is in third semester or was in second
No,
semester?
sir, in this semester Third
Hmm.
semester, sir.
Data structure is in third semester.
Third Yes. semester.
Third semester. Okay. In the data structure you will get the same topics. Okay, hash function, growth functions, matrix representation of relations as well as the functions also. Many things you will get on this data structure. By the way, next that means in the coming we will try to just complete this predicate and quantifier, so that the first module and module 2 will be completed, and after that we will start the module 3. Okay.
Yes, sir.
So you take the screenshot of this. So we start from here actually. This is the continuation of the problem, so take it. Take it.